Imagine an AI that can see, hear, and speak to you all at the exact same time. Welcome to the explainer on MiniCPM-o 4.5.
Seriously, what if your AI didn't politely wait its turn to process a video before responding? Picture watching a live cricket match with an AI that just shouts and reacts in true real time, right alongside you without taking turns. That's the incredible leap we're getting into today.
And right out of the gate, I want to explicitly mention that we are sharing the full article and the exact code to reproduce the results you'll see today. You can find that link right down in the description or the pinned comment below. Okay, let's dive into this roadmap and break down this massive leap in multimodal AI. First, the turn-based AI problem. Second, meet MiniCPM-o 4.5. Third, synchronizing sight and sound. Fourth, real-world AI experiments. And finally, the open-source future.
Section 1. The turn-based AI problem.
So, why do we even need this? Well, traditional models suffer from a huge issue: temporal staleness. Basically, if you feed an AI a live video, it literally can't update its ongoing response if something new happens on screen while it's still talking. On top of that, there's absolutely no proactivity. It only responds when you explicitly ask it to. Compare that to natural human interaction, right? We react in real time, and we speak while we're listening to the world around us.
Section 2. Meet MiniCPM-o 4.5.
Before we open up the hood, I need to let you know, this video is sponsored by BigVision.ai, a consulting and product development company that helps companies of all sizes build computer vision and AI solutions. You can reach them at contact@bigvision.ai.
All right, so how on earth does this actually work? Instead of running separate, clunky services for vision, audio, and text, this 9 billion parameter model wires everything directly together. It kicks off with a vision encoder, SIGLIP2, which heavily compresses video slices to save compute. Then, an audio encoder using Whisper streams the sound into features. All of this feeds straight into the LLM backbone QN38B, where the actual multimodal reasoning happens. Finally, lightweight speech decoders turn those thoughts straight back into audio waveforms. It's one beautifully connected pipeline, right at the token level.
Section 3. Synchronizing sight and sound. The real secret sauce here is a framework they call Omni-Flow. Omni-Flow basically aligns the video, the audio, and the model's output onto one shared timeline split up into fixed 1-second chunks. Every single second, the model takes in new video frames and incoming audio, decides whether it needs to stay silent or speak up, and then generates its output. As it turns out, 1 second is the absolute sweet spot to give the AI enough context to make a stable decision without any annoying lag. Now, what's really interesting about this slide is how it solves a super subtle problem. You see, text generates way faster than spoken audio. If the AI generates text too fast, its spoken voice will start lagging behind the live video. To fix this, the system uses time-aligned interleaving, or TAIL. TAIL tracks the accumulated playback lag. If the voice falls behind, it literally forces the model to generate fewer text tokens just to let the audio catch up. It also uses a tiny look-ahead window for correct pronunciation without letting the text stream run way ahead of the video playback.
Section 4. Real-world AI experiments.
Let's look at this in action with some live sports commentary. The researchers tested the model on a football penalty clip with a prompt to act as a commentator. The crucial point here is that it wasn't prompted every single second. It just watched the video continuously, stayed completely quiet during the routine play, and proactively spoke up the instant a notable moment happened on the pitch. No turn-taking required. And his next one brilliantly illustrates its potential for security analysis. In a retail surveillance experiment, the model watched a live feed of a phone display counter. It didn't just give basic, boring narration, it actually tracked a behavioral pattern of rapid grabbing and concealment. It escalated its narration proactively from neutral descriptions to flat-out stating, "The person appears to be stealing." It made that judgment call entirely on its own.
They also ran a cooking narration test where the model was narrating a close-up food preparation video in real time. Suddenly, researchers injected unexpected audio questions into the stream. When asked what fruit is being scooped, the AI smoothly paused its narration, answered avocado, and then correctly answered bread to the next question, doing all of this without losing its place or breaking the continuous flow of the video, just like a real person would.
Oh, and we definitely can't forget voice cloning. The model achieves stable, zero-shot voice cloning right out of the box.
You simply passed a reference audio clip into the system prompt, and the model perfectly matches that tone directly for its live speech generation.
You keep your eyes only on me, understand? Don't look down, don't look around me. I'm taking you to the car, and you're gonna want to look around. A man in a blue shirt is running along the waterfront path. He's wearing black shorts and red shoes, moving steadily forward.
Naturalism is a frantic escape from the responsibility of volition, of choice, of values. A man in a blue shirt is running along the waterfront path. He's jogging past other people who are walking or also exercising.
During testing, there was absolutely zero voice drift. It held the cloned persona flawlessly the entire time.
Section 5. The Open Source Future.
When looking at the benchmarks, it's pretty wild. For a compact 9 billion parameter model, MiniCPM-o 4.5 absolutely holds its own in instruct mode against massive players like Gemini 2.5 Flash and Qwen 3VL 8B. It delivers highly competitive scores across OpenCompass, MMBench-EN, and MathVista. It just goes to show you really don't need a massive closed-source model to get incredible multimodal performance anymore.
And the efficiency? It is just staggering. This quantized model can run completely locally, utilizing just 11 gigabytes of memory. Let that sink in. That means you can achieve full duplex, real-time AI streaming on a single, consumer-grade RTX 4090 GPU.
So, what does this all mean for us? The crucial question we are left with is this: are we finally entering the era of true conversational AI? With open-source models that natively see, hear, and talk back without waiting their turn, we are definitively moving away from clunky, turn-based chatbots. We're stepping into a world of genuine, real-time conversation partners. And honestly, that changes everything.
Thank you so much for watching this explainer. Please make sure to like, comment, and subscribe for more deep dives into the absolute cutting edge of technology. We'll see you next time.